the script there says, "Hey, look, it's Jacob." There's
Oh,
Jacob, right
hey,
there.
look.
It's
Jacob.
Yeah. You know
We
what?
don't really read scripts, do we?
We don't read scripts, but it's fascinating, their topic today, because I will admit that this is not one of these centers I typically go to, being in North Dakota, but it's a fascinating one at that.
We're kind of far away from the oceans,
Yeah.
but it has big impacts on the entire globe, what happens over the oceans, as well as with the entire shipping industry. So we're working through the National Centers for Environmental Prediction here, now talking about the Ocean Prediction Center. So the OPC, their forecasters continuously monitor weather across the North Atlantic and North Pacific Oceans and issue warnings and forecasts out to 5 days for wind, heavy freezing spray, and other sorts of advisories that are important for ships, because the international shipping industry is responsible for the carriage of about 90% of the world trade, and you get all these shipping routes that can be impacted by weather, so it's a vital service that the OPC provides. So they're located in College Park, Maryland. They have forecast desks for the Atlantic Basin, the Pacific Basin, as well as for medium range forecasts. The offshore regional zones are about 200 miles off of the east and west coast of the United States. Beyond that is deemed the high seas, and they also have forecasters for that region. So they collaborate with the National Hurricane Center for the tropical regions, the Weather Prediction Center that we talked about a couple weeks ago, because they forecast weather over land over the United States, and then that weather bleeds into the oceans, of course, and the Hawaii National Weather Service office, located obviously in the middle of the Pacific Ocean there. But the kind of core component that they start with is surface analysis. So this is the current surface analysis across the Atlantic Ocean. Here's the United States. I drew the coastline here. You can see where the fronts are, the areas of low pressure leading to higher winds and rougher seas, and then the coast of Europe on the side there. But Logan at the OPC will kind of explain why these surface analyses are critical.
The backbone of our forecast process is the surface analysis that we actually do 4 times a day on both of the high seas desks. There are not a lot of observations out over the oceans, especially relative to the number of observations that we have over land. So for doing the surface analysis, we're heavily dependent upon satellite data as well as model data.
So to draw these and then issue forecasts, buoys, satellites, those are important. And an interesting thing with satellites is they have this thing called scatterometry, which really indicates where the winds are blowing, what direction, and the speed over the land, with kind of some satellites that are a little bit closer to Earth's surface, polar orbiting satellites. But with the wind and the wave forecast, those are kind of the 2 critical components that they have here. So here's looking over the Pacific Ocean right now with some rougher seas, higher wave heights just off the west coast, because we have a couple areas of low pressure here, and that's churning up the ocean. But watch this area of low pressure east of Japan, kind of in the north central Pacific Ocean. Then here's their forecast 48 hours into the future. That area of low pressure and then leading to higher seas, rougher waters, is near Alaska. So that forecast into the future is really important. But the surface analyses serve as a basis for their short-range forecast, specifically with wind and waves. Those are the 2 most critical components.
Our biggest 2 forecast parameters, I would say, are winds and waves. We forecast and analyze what we call significant wave height. A significant wave height of 6 feet might mean that you could see waves up to twice that height. So that sort of information helps mariners know what kind of sea states they might be encountering.
And then to have a whole unified analysis, they have this map here stretching from Asia all across the Pacific Ocean, the United States, and then all across the North Atlantic Ocean. So they also forecast visibility, dense fog, that's important for mariners, as well as lightnings, because thunderstorms can cause winds to be locally higher and be variable in directions. So they also have automated products for wind and waves. Those forecasts are reliant on global forecast models that solve the equations that represent our atmosphere all around the globe. And the forecast products are on their website. They can also broadcast those forecasts over satellites and high-frequency radio directly to ships, which is a way to get those impacts to the end user, to those ships at sea. Now, their core partner, one of them, is with the Coast Guard. So they have briefings each week for impacts off the U.S. East and West Coast for Coast Guard rescue missions. So they can see the actions that are being taken out at sea, because these ships are receiving the forecast from the Ocean Prediction Center and then reacting if there is a rough area of weather and higher seas, rougher waves. Satellites can show where those vessels are and the paths that they're taken, because they're trying to avoid the most hazardous conditions. It's important for these people out at sea to know the conditions well in advance so that they can avoid the area, take action ahead of time. Now, another part of the Ocean Prediction Center is with ice coverage. They have partnered with the U.S. National Ice Center to figure out what the extent of ice cover is over the Arctic and Antarctic. So they use satellites to show that snow and ice cover, plus over the Great Lakes too. So that information helps support the U.S. defense interests, as well as for research vessels in the Arctic specifically. And that snow and ice cover can even be put into forecast models because everything's connected with the ocean up towards the atmosphere. So we might not think about the oceans being that critical to weather here locally, but even if it's not impacting our weather and everything's connected, the shipping industry is huge. Most of the products that we get are on a cargo ship, and they come into a port of entry in the United States, and that cargo ship has to make a trip all across the Atlantic or the Pacific Ocean, and the forecasts from the OPC are really critical to ensure that that ship safely makes it here.
No doubt about it. I mean, it's so cool. I mean, that's a whole, that transportation sector is
Right.
amazing in the oceans.
Yeah.
It really is. So it's a good service to have, obviously. A lot, I just learned a lot there too.
There you go.
All
A
right.
lot of information there,
Thanks
so.
as always, Jacob.
Yeah.